Alright, let's talk about the product rule. Basically, I have the formulas for the product rule right here. There's really the same formula, and this is how it works. So if you have two things that are being multiplied together, or two functions that are being multiplied together, then when you take the derivative, you can't just do the derivative times the derivative. Can't do that. But what you can do is the derivative of the first times the second plus the second times the derivative of the first. And since you're adding, you could actually change that order there. That's okay. If this was a subtraction, though, right, we wouldn't be able to change that order. But since you're just adding, you could do it in any order. Another way I kind of write this is something like this. You could say the derivative of a times b is going to be the derivative of a times b plus a times the derivative of b. Pretty simple pattern. Pretty easy. You just have to know that the derivative of one of the functions is going to go with the original of the other and vice versa and add them together. So let's practice it. Okay, so here we see we have two functions being multiplied together. We got the 3x squared and we got the ln x. And you have a couple options how you want to deal with this. You could just leave the 3 out in front, or you can make the 3 just a part of this function, which is kind of how I'm going to handle it. So let's just go ahead and do it. So I know that it's going to be, I'll write it up here, the pattern up here. Remember, the derivative pattern of the product rule is basically this. Derivative of the first times the second plus the first times the derivative of the second. So the derivative of the first, well, that's easy. 3x squared, that's just simply 6x. And then I'm just going to multiply that by ln of x plus the first times the derivative of the second. The second is ln x, so the derivative is 1 over x. And we can simplify from here. This would just simply be 6x ln x plus, technically you're multiplying by 2 x's here and then dividing by 1, so you could kind of just cancel that out. And there you go. Of course, there's multiple ways you could write that, right? So keep in mind you could factor a 3x out of both of these terms, and you could write the factored form. So it might look something like this. Right? And so I just want you to be aware for stuff like that, because you never really know how they might write the multiple choice answer. So just be able to manipulate your results using some basic algebra skills in order to find the right multiple choice answer when that's the case. Okay, so I got another example here for you. I want you to try this one on your own. Simple product rule. Remember to use the simple product rule pattern. Give it a try, and then I'd pause the video, give it a try, and then check back in a couple minutes when you're ready to see how I did it. Okay, so you gotta love these e to the x problems. Pretty easy. The derivative of e to the x is just e to the x times the second, so I just literally copy that down, plus, well, I'm just going to, again, copy down e to the x, because I'm just copying down the original function, and then multiply by the derivative of 3x to the negative cube, which would give you negative 9x to the negative fourth. I simplified these as fractions here. Then I noticed it would be pretty easy to get common denominators, so I multiplied this one by x over x, and I got it to look like this. This may be an acceptable answer here without the x over x here, but I just want to show you how you could write it as one fraction. It's always an option. Okay, let's take a look at example 2. So here's an example of one where you have an option here. You could multiply these things together and then take the derivative, or you could do the product rule. I honestly think multiplying together first and then taking the derivative is the easiest. I'm going to do that first. So let's see here. I'm going to put this as 3x, this is negative 2x squared. And let's just multiply them together. So 3 times 5, that's 15x. That's going to be 12x squared. That's going to be negative 10x squared. And that's going to be negative 8x cubed. And so I could simply write this as negative 8x cubed. Those are like terms, so that turns into plus 2x squared plus 15x. Okay, well, now that's easy to take the derivative of, because then I could just use the power rule, and I get negative 24 x squared plus 4x plus 15. Okay, see, I think that was pretty easy, but just to show you, in case you didn't know that, we could still use the product rule. So let's go ahead and give that a try. We're going to do the derivative of the first. So I'm going to use parentheses to kind of keep this all organized. So the derivative of the first, that would just be 3 minus 4x times the second, so that'd be 5 plus 4x, plus the first, which is 3x minus 2x squared, times the derivative of the second, which would just be 4. And I could, again, kind of box method or FOIL these. I'm just going to FOIL these because I'm running out of space here. 3 times 5 is 15. 3 times 4x out here is 12x. And then on the inside I have a negative 20x. And then lastly I have a negative 16x squared. Plus, let's distribute this 4, we'd have a 12x and a negative 8x squared. So, I see I have some like terms, and that tells me that's going to be a negative 24x squared. Got rid of those. I have some more like terms. So I have two positive 12s, that's 24 minus 20, that's going to be a positive 4x, and then plus 15. That's all that's left. And so I got the same thing, but I think you saw that if you can multiply them together ahead of time, it's a lot easier, right? That was a lot quicker than all of this. Either way, though, we did get the same thing. Doesn't matter which way you do it. I just do want you to see if you can take some... There's shorter ways to solve problems, and I want you to be able to apply those skills. All right, let's go to the next problem. Okay, pretty simple one here. This is just x times sine x. So what I'd like for you to do is just give it a try, pause the video. When you're done, you're ready to check your work, go ahead and unpause it. Okay, pretty simple. Derivative of x is 1, then you put the sine x plus the x. I'm just copying it right down. The derivative of sine x is cosine x. Simplifies nicely. Not that hard of a problem. All right, here we got one that's got a little bit more going on. We're going to have to do chain rule here, but this is not really chain rule because this is just a coefficient. If you thought about it as chain rule, this would be the derivative of the 2 would just be 0, and so you'd only end up with one term. So you really just have to kind of just leave this out in front as a coefficient. So let's do this first, and I'm going to treat the 2x as my first term. So that means the derivative of the first is just 2 times cosine x plus 2x. The derivative of cosine x, remember, is negative sine x. And then this is going to be, I'm going to leave that negative 2 out front. The derivative of sine x is simply cosine x. Well, hopefully you'll see here you have a positive 2 cosine x and a negative 2 cosine x. So those guys cancel out, and you're left with a negative sine x times 2x, which is just negative 2x sine x. And that's it. All right. Okay. Pretty nasty one here. I would recommend multiplying these things out first and then taking the derivative. It's going to get pretty crazy. If you don't want to do it that way, you can use product rule. Just a lot of things that can go wrong here. So trust me and try multiplying them out first. I recommend you pause the video, give it a chance, and then check back to see if you're right. Okay, so I went ahead and multiplied them together first because I could. You just use the box method, just made a big 3x3 box, and I'm just multiplying them all together. And I ended up with this. Now this is really easy to take the derivative. I just have to use the power rule, and I got 8x cubed minus 3x squared plus 2x minus 7. Alright, now that's it for the product rule. Pretty simple, but we'll play with the quotient rule on the next video. See you guys then.